We are from the University of Tokyo, and I will talk about the overview of our approach, and because our model is very similar to the baseline approach, so I will talk them together, and then I will talk about the experiments and the results and the future work. For the data, we have 3 types of data, but we only use the Mel-spectrogram. The Mel-spectrogram is like that image. It maps the frequency to the Mel bands and present the and represent the audio into many frames. When talks about the non-time audio recognition, we will think about the CNN, and we usually use the CNN to extract the temperature feature and use the RN to aggregate the features. But our teams have no enough time to design the CNN model, so we only use the CNN. For this task, our goal is to find the most suitable CNN for this task, and we use CNN to predict for each audio segments, and then we average the results. The audio tracks in the dataset are all longer than 30 seconds, and for 30 seconds audio tracks, the Mel-spectrogram, the size will be 96 millibands and 1,408 frames, and we think that our input segments should be slightly shorter than the 1,408 frames, so we decided it to be 1,280 frames. For the baseline model, we think we tested it, and it achieved good performance, and we think this is very memory saving because it only have 5 CNN layers and only have a max unit number of 128. However, we think there are too few units in the master layer, and it has relatively large size of the max polling layers. So our model have a better design of the units of each convolutional layers, and we have more units in the master layers. What's more, we change the product for max polling layer to two product to max polling layers, and this is the difference compared with the baseline approach. And we also tried deeper models, like over 16 layers, and some of them have the residual architecture, but we have not enough time to design the network and they didn't achieve a good performance. For the experience, the input length is 1280 frames. For the training dataset, we randomly extract a segment from the all audio tracks, and for the validation and test dataset, we respectively extract 10 and 20 segments at regular intervals. For the reason of our cropping method, we found that there are over 80% of the audio tracks. They are shorter than 1300 frames. So by our methods, we can covering 80% of them without overlapping in the validation, and for the test we can get the 50% of overlapping, and there is other parameters. Our 6-layer models achieved the best performance in our experience, and for deeper models, they didn't achieve a better performance. And here is the top 5 and the bottom 5 results. I think they are very similar with the baseline approach, like the subsummer and deep in the top 5, and sexy travel in the bottom 5. In conclusion, the VGG based and really shallow achieved the best performance, and we think the robustness is very important for the task. So we plan to improve the design of our research-based models, and we also want to try CRM-based models, and now we only use the Mel-spectrogram, and so in the future we want to do a multimodal. Yes, it's all. Thank you for your attention.